So earlier we talked about exponential growth and exponential decay. So now what we're going to do is we're going to talk about some application problems. In order to do these problems, you have to know the basic formula. The left side is your final population or a final amount. The P sub 0 or P naught is the initial population or the initial amount. And then R is the rate. The rate is always the percent, and then T is your time. So the first one says, how long will it take $1,000 to grow to $1,700, earning a 5.5 interest rate compounded continuously? So this is going to be the initial amount. So that's P0 or P naught. This is the ending amount. So that's P. And then this obviously is going to be your R. So using the formula, we're going to have 1,700 equals 1,000 E. Now 5.5 has to be converted, so we'll move the decimal over 2 places, so it's 0.055. And the question is asking how long. We don't know how long, so that's going to be T. So to solve this, the steps are the same pretty much on every single question. First, you want to isolate your base, so you're going to divide by 1,000. And we could actually simplify this so we can cross out those zeros. So this is just 17 over 10. And then you're going to have E to the 0.055 T. So at this point, we're kind of stuck because the T is in the exponent position. So what we want to do is convert it. So E converts to an ln, and then the stuff just swaps. So we'll have 0.055 T on this side, and then we'll have 17 over 10 on this side. The last step is to get T by itself, so it's 0.055. So you're dividing by 0.055. And at that point, you just put in the calculator now. So the calculator, you'll go into the regular calculator mode. Let me delete all this. And I'll hit ABC, ln of 17 over 10. So I'm going to stick 17 on top, 10 on the bottom. Put a 10 at the bottom. And then at the bottom of the fraction, we're dividing by 0.055. So we're going to round this to the third decimal place, so it's 9.648. 9.648. And that's our answer. Okay, the next one we're going to talk about is bacteria. P e to the RT is often used with bacterial growth. Now, the thing about these questions, though, is when we deal with this bacteria stuff, it's actually a two-step question. You're going to find that they hardly ever give you the rate. If you just scan the question, you can see that there is no rate. So it says a culture of bacteria originally numbers 250. So that's your P naught or P sub 0. After 3 hours, there's your time. So that's T. There are 900 bacteria present. So this is going to be the final amount. So that's P. Assuming the exponential growth, how long will it take, blah, blah, blah. Okay, so first part is to figure out what R is, because there is no percent in this question. So the original amount is 250. E to the R, we don't know what R is, but we know that it takes 3 hours at this rate in order for there to be 900 bacteria. So the steps to solving these exponentials are pretty much the same every time. You're going to divide out the 250 in order to get the E by itself, and we can go ahead and simplify that also by crossing out those zeros. So we're going to end up with E to the 3R and then 90 over 25. That simplifies more, but I don't really care. So now we're going to convert. So this is going to give me ln of 90 over 25 equals 3R. Then we just divide by 3. Divide the whole thing by 3. And then that just goes into the calculator. So we're going to have, what is it? Fraction ln of 90 over 25. Not 9 points. It's going to be 90 over 25. And then the bottom is going to be 3. So we divide that, and it's approximately 0.427. So R equals 0.427. Now, when I do this in the calculator, I'm actually not going to use 0.427. I'm going to hit shift, what is it? Shift negative to put in that entire decimal. See, the thing is, when you type this stuff in the calculator, the fact that we cut off the rest of the numbers causes an error. It's called a rounding error. So we're going to get started over here on the real question. It says, assuming exponential growth, how long is it going to take until 10,000 bacteria are present? So this right here, this is going to be the new P. So they wanted to end up with 10,000 bacteria total. Now the beginning amount is still 250. So we're going to start off with 250 E. And I'm going to put this part in red because I mentioned earlier, I'm not going to actually type this in the calculator. So this is going to be 0.427. In the calculator, I'll use the ANS button, which is the previous answer. And it says, how long is it going to take? So we're going to try to solve this for T. Now, the steps to this, again, they're pretty much the same every single time. So the first thing you do is divide by 250. So divide this by 250. And you can cross out some of those zeros. These cross out, so we have e to the 0.4277t. I don't like the way I wrote that. Let me rewrite that really quick. So e to the 0.427t. And I think that reduces. So let me do 100, or no, that's 1,000. So we got 1,000 what the heck? 1,000 divided by 25, 40. So that's just 40 right there. And now we can convert it to the ln. So we're going to do ln of 40 equals 0.427t. And then I just divide by 0.427. Divide by 0.427. These cross out, so t equals. Now when I type this in the calculator, I don't want to have that rounding error occur. So what I do is I type ln of 40 on top, so there's no issue there. But on the bottom, instead of using 0.427, it's supposed to be 0.426977945 blah, blah, blah forever. So what I'm going to do is I'm going to hit shift and negative, and it puts in, actually that's not going to work because it's going to put in the 40. Sorry about that. So I am going to use 0.427. 0.427. The reason why I didn't use the ANS button is because it would have put in the previous answer, and that previous answer is that 40 right there. So this is not going to be super exact, but it's going to be pretty close. So it would take I forgot what the number was, 639. 639. And you're going to see that in a lot of these bacteria questions, it's going to be a two-step. You have to find the R first, and then once you find the R, you got to actually use it in your question. Okay, so now the last one we're going to do is a real famous one. They call these ones half-lives. Now, in a half-life question, it's going to appear that they didn't give you all of your information that you need. So what we're going to do here is we're going to use the fact that half-life means that's how long it takes for half of it to happen. So it says there's 300 kilograms present initially. That's the beginning amount. So it's going to be 300 E. The R, we never know R because in these bacteria questions, they never tell us what R is. Bacteria and radioactive substances, they hardly ever tell us what the R is. And it takes 50 years for there to be half. So the number that they didn't give us is half of 300. So that's going to be 150. So we have to just understand that anytime it says a half-life, you're going to have to cut the beginning amount in half. Now the math that you do here is always going to divide the number in front of the E, and then this is always going to be a half. That's what happens on these half-life questions. So it's going to be E to the 50R, and then we're going to convert it to an ln. So it's going to be ln of 1/2 equals 50R, and then we divide by 50. So divide that by 50. So in the calculator, we'll have fraction ln. I'm just going to type in 0.5 for 1/2, and then at the bottom, we're going to stick 50. You're going to notice that this answer is negative, and the reason why that happens is because the amount is shrinking. Anytime you have a shrinking amount, you'll have a negative R. So we're going to use 0.014, negative 0.014. And this is our R. Forgot the R right here. So again, I think on this one, I will use the ANS button. So we're going to start off with 300 E, and then this is the new T, but we know that the R is negative 0.014, and we want to multiply that now by 15. So this all goes into the calculator, so I will put in 300, shift ln. So remember, I'm not going to put negative 0.014, I'm going to use the entire decimal, so I'm going to hit shift negative, and then times 15. So that's how much, what do we have here? How much substance we have left. 243.676. So 243.676. And I just want to go ahead and show you real quick why I'm using the ANS button. When you don't and you actually round, you end up with a slightly different answer. It's not that huge of a difference, but it is kind of a difference. So we're going to put negative 0.014 times 15. So just so you can compare, it's very, very slight. You can see it's 0.6, and over here changes to 0.1. So the more numbers you use, the better answer you get. I'll probably have both on my answer key when we take the test. I know for the answer key on the assignment, though, I did not use the ANS button. So you could do it either way. And that is how you do exponential growth and decay.